Good afternoon, everyone, and welcome to today's joint webinar on intelligent orchestration across the Edge Cloud Continuum. My name is Despina Kopanaki. I'm a senior project manager at the Technical University of Crete, and I am the Elastic project manager. I will be your moderator for this session. This webinar brings together the Elastic and 6G-Path projects, two European initiatives working at the forefront of next-generation 6G systems. Today, we will explore how intelligent orchestration can enable scalable, efficient, and secure services across the Edge Cloud Continuum. On behalf of both projects, I would like to sincerely thank you for being here today with us. Before we begin, just a few quick housekeeping notes. This webinar is being recorded, as you noticed. If you do not agree with the recording or the data processing policy, we kindly ask you to leave the session at this point. We kindly ask you to keep your microphones muted and your cameras turned off throughout the session. You are very welcome to submit your questions at any time via the Zoom chat, and we will address them during the Q&A session at the end. So why we are here today? This webinar is a joint initiative between the Elastic and 6G-Path projects, both funded under the Smart Network Services and Services Joint Undertaking Program. Our goal is to address shared challenges in Edge Cloud orchestration and to create meaningful synergies across projects and research communities. We aim to explore how we can enable more scalable, flexible, and intelligent service deployment while also contributing to the evolution of secure and efficient 6G systems. Let me now introduce our first speaker, Professor Tarik Taleb. Professor Taleb is a full professor at the Dhouha University Bochum and head of the Mosaic Lab. He's a leading expert in 5G and 6G networks, AI-driven orchestration, and cloud edge systems. He has held academic positions at Aalto University and the University of Oulu, and also brings strong industry experience as a 3GPP standard expert at NEC Europe. He's also the founder of ICT Global Research Network. Today, he will present the 6G-Path project and the Miro orchestrator. Our next speaker is Dr. Dhouha Ayed from Thalys 6. Dr. Ayed is an expert in 5G networks and system security with more than 18 years of experience in secure systems and future networks. She has been the technical coordinator of multiple European research projects and is actively involved in European working groups and standardization activities. Her work focuses on AI-driven security for next-generation networks. Today, she will present an overview of the Elastic project. Also, Dhouha is our technical coordinator. Our next speaker is Drasko Draskovic from Abstract Machines. Drasko is an expert in IoT and cloud computing with more than 20 years of experience in distributed systems. He has held roles at major industry players such as Texas Instruments, Alcatel, Lucent, and Nokia. He is also a contributor to the Linux Foundation EdgeX Foundry and serves as the technical manager of the confidential 6G project. Today, he will present Propeller, a lightweight orchestration solution for Edge cloud environments. Let me briefly walk you through today's agenda. After this introduction, Tarik will present the 6G-Path project and the Miro orchestration framework. This will be followed by Dhouha, who will introduce the Elastic project. Next, Drasko will present the Propeller orchestrator. Finally, we will conclude with a joint discussion and Q&A session. But before we move into the presentation, we would like to get a quick sense of our audience today. We have prepared a very short poll with 3 questions. Yelena, if you can please launch the poll. I'm not sure. Yes, now. So a pop-up window that includes 3 questions appears in your screen right now. The first one is related about your background, academia and research, telecom operator, digital technology provider, service provider, SME or startup, policy public sector, civil society, NGO, citizen or end user. We will have 30 seconds for this poll, so please provide your replies. Which of the following areas are you most familiar with? edge cloud orchestration, AI-driven orchestration, lightweight orchestration, 6G next generation networks. And the last one, what is the biggest challenge in orchestrating edge cloud environments, scalability, interoperability, automation, intelligence, or security? So I am doing it together with you. I see that we're receiving some replies, but we need more. Okay, 10 more seconds and we will close the poll. Okay, Elena, can you please present us the results? Great. We see that the vast majority today is from research and academia, also SMEs and policy public sector. Great. Regarding the second question, I see that we are covering all of the areas, and I'm very happy to see that, mainly 6G next generation networks. And the last one, and this goes to our speakers, the biggest challenge, I assume it's scalability, and then security. So without any further delay, Tarik, the floor is yours.
Okay. Thank you, Despina, for the introduction and also for this very nice and very interesting poll. Can you please confirm that you can see my screen in presentation mode?
Yes.
Okay, excellent. All right. So as you have introduced, actually, this work is being conducted within the 6G Path project, which is one of the European projects, which is actually part of this webinar. I myself from RUB, but I've been actually involved in the 6G Path as part of the ICT official company. Yeah. So I will give a very quick introduction to the project, 6G Path. The project, this is the third year of the project. It's supposed to finish by the end of this year, but we are also thinking about an extension. The project consists of 26 partners, which are actually across 13 European countries. It's coordinated by OTE, which is the number one operator in Greece, and the technical coordinator is OneSource. It's an SME in Portugal. The core concept of the 6G Path project is to facilitate the integration of different beyond 5G technologies and validate them in our test beds. We have 7 test beds and across different use cases. So these technologies, they're coming from phase 1 projects, from Horizon Europe and Edge 2020 projects. They come also from the third-party contributors that are actually invited through open calls, and they come also from within the consortium. The goal of the project is to set up experiment and validation infrastructure and evolve them towards these beyond 5G technologies, enable the integration and implement large-scale field trials with internal and external experiments, and collect and refine the requirements. And then we have also, we look also into the exploitation of these technologies and disseminate the work within Europe and across the world. Okay. We have actually 7 test beds that are coming from within the consortium. They are actually coming from different institutions involving 5 European countries. And we have also 2 third-party test beds, as you can see here, the orange one. And these test beds, they are actually supposed to be incubators of the technologies that we develop within the project, that we import from outside, and they are validated against these use cases. The use cases, actually, we have 10 use cases, as you can see here, but they are organized in 4 categories. We have use cases that are actually about the smart cities, use cases that are about the education, use cases that are about the health, and then use cases about farming. And here you can see, some of the technologies that are actually being used in each of these use case areas. So that was very quick about 6G Path. And now I would like to introduce one of the technologies actually that we have in 6G Path, which is the Miro system. And the objective of this Miro system goes really in line with the title of the webinar, which is enabling intelligent orchestration across the edge cloud continuum. I would like to make one very important disclaimer. As I mentioned earlier, there are 10 use cases, 9 test beds that actually involved in this project. We have identified many beyond 5G technologies from within the consortium, as well as from outside of the consortium. And these beyond 5G technologies, they are actually reported in one of the latest deliverable of the project, which is deliverable 3.2. If you visit the website of the project, you will be able to find it. And this is the list of these technologies and how they are used actually in the 6G Path testbeds. So because of time, I cannot cover all of these technologies, and that's why actually I'm going to focus on one of them, which is the Miro system. And the Miro system is really in line with the objectives of this webinar. So what does Miro stand for? Miro stands for Multi-Domain Intelligent Resource Orchestration. It's coming actually from 2 SMEs, OneSource, which is the technical coordinator of 6G Path, and ICT Official, which I've been involved in. Some little background behind Miro and its history. It started actually within charity. This project has already finished, and it was all about how to enable immersive services, how to enable the deployment of immersive services on cloud, on edge cloud. And then it was used in Rigorous. It's a European project that was about security. And basically, we tried to use it to enable certain security features of Rigorous. And it's been worked out within the 6G Path project. So little motivation behind the Miro system. As you know, there are lots of use cases that were aimed for within 5G, but they could not be achieved. And that's why we inherit them in 6G. And there are also some new use cases that are coming specifically for the 6G system. This is just a list. And these actually snapshots, they are taken from 6G flagship promotion video in Finland. But in short, if we want to characterize the 6G services or beyond 5G services, in short, there are services that will be contributing a lot of data in the uplink. They will be contributing continuous and constant streams of video and sensor data, actually in the uplink as well as in the downlink, but the uplink contribution will be much more in comparison to the previous generations. And the thing which interests us in the context of Miro is the fact that these services, they will be consuming data coming from or to a backend system which is cloud native. And this backend of these 6G services will be deployed on not only one single cloud domain, but on multiple cloud domains, and they have to be deployed in an autonomous way. And also some of these interaction between the services, the end users, and the service backend system has to be done in a deterministic way. And the deterministic requirements here could be in terms of latency or in terms of bandwidth. So these are actually the main characteristics of 6G services, and this is basically what has motivated the work behind Miro. So to illustrate this with more clarity, these are just few examples of use cases that are envisioned in the context of 6G. You'll be having autonomous cars that will be sources of lots of sensed data, video data. You'll be having UAVs, you'll be having robots, or you'll be having just people, doing this kind of 360 crowd sensing, or just live streams of videos or 360 videos. And then you'll be having fleets of mobile robots that need to communicate among themselves and keep on transmitting data, most probably heavily in the uplink. These services, they have a backend system, and this backend system is running on different cloud domains. These domains, they are different in terms of technology as well as in terms of administrators. So they could be belonging to different operators like Amazon, Azure, Google Cloud Service, or your own OpenStack managed cloud. And these infrastructure, they are not used by one single backend system, but they will be used by other backend systems. So there is a sharing of the physical infrastructure. And when we speak about cloud nativeness, of course, we talk about microservices. Of course, these backend systems, as well as the end users, they will be kind of operated with their own AI agents. But these AI decisions, they will be internal to the services. And we need something that can have actually a big view of the infrastructure on which these backend systems are actually being deployed. And that's actually the scope of Miro. So Miro facilitates the deployment, the initial deployment of these backend systems, taking into requirements latency, deterministic bandwidth, migration, and also it supports the lifecycle management of the backend system. Okay, so now that was the motivation behind Miro. And now if we want to introduce Miro in very brief, it's an intelligent, user-friendly orchestration platform that empowers organizations to optimize their edge cloud infrastructure, drive growth and innovation, and succeed in rapidly evolving cloud-native landscape. The design principles behind Miro, one of the most interesting or appealing design principle is the fact that we try to decouple the intelligence from the enforcement layer. So basically, the Miro system, the Miro architecture, if we want to simplify it, it can be simplified into 4 main components. So you have the user interface, the graphical user interface. And then you have the monitoring system that keeps on collecting data about the infrastructure itself. And then we have 2 types of orchestration. We have what we call the high-level orchestration and the low-level orchestration. The low-level orchestration is the one which is doing the enforcement of whatever decision that comes from the intelligent layer of the system, which is this high-level orchestrator. So basically, this does the enforcement, and this one has the intelligence to decide how things have to be deployed. And once the decision is taken, it's communicated to the low-level orchestration and it gets enforced. Yes, these are actually these are the 4 main components. And with this design, we kind of achieve AI nativeness in Miro. And how that is possible, let's say that we have here monitored data. So basically, for each objective, for each decision, and this decision could be the initial deployment, it could be the migration of a service or migration of the whole service, the set of microservices that are actually forming that backend system. So there could be different decisions, and these decisions, they have to be taken in an autonomous way based on an AI algorithm, and this AI algorithm has to look into the data. So basically, we have here a pool of monitored data. We need to get filters for the data. So basically, if you're looking at whether to scale up or scale down, then you have to look into the CPU usage, memory, and based on that, you can decide whether to scale up, scale down, or horizontally, vertically, and so on and so forth. And each of these, this is one pipeline which is for one single decision making, but you could have actually the same logic for different, different decisions, and these can actually work in parallel. Now, how we achieve this AI nativeness is by actually today, for example, we can use an AI algorithm that is powerful, let's say for migration. But tomorrow, if there is something else and a better model, then we can replace this by the new advanced model, and this will not impact, the working or the processing of the Miro system itself. And this is how we define AI nativeness in Miro. As I mentioned earlier, what kind of decisions could be done? Of course, the initial creation of the cluster. I mean, here we assume we're working with Kubernetes, so basically Kubernetes cluster. Initial placement of the services, microservices, initial allocation of the resources, the migration of one single microservice, or the migration of the set of microservices that are forming, let's say, the slice. Service elasticity, basically scaling up, scaling down. Economical denial of sustainability. So basically, yes, it's possible to, if the system is being full, and then you have requests to scale up when you don't need to do the scaling up just because the attacker wants to cause some kind of economical denial of service. There are also mechanisms to find out that, and then you don't allow the scale up requests. Of course, you can do it also for energy efficiency and so on and so forth. We have been looking in leveraging different AI techniques to achieve some of these objectives. And of course, for the sake of time, I cannot cover all of them. And if you are interested, you can visit Mosaic Lab website. We have papers about each of these. Yes, Miro is more complicated than what I presented. There are lots of different open sources that we are using for different purposes. If you want to know more, feel free to contact us, and we will be more than happy to share with you insights. For the time being, what I would like to do is to show you how it works through this video, and I hope that...
Welcome, everyone. This video introduces our latest achievements from the Miro project, our new cloud-native orchestration solution. Miro is designed to simplify the management...
Oops, sorry, don't know what happened.
...of Kubernetes clusters and deployment applications within the complexity of multi-domain cloud-based environments. First, let's rewind a bit. In the past, applications were big, bulky monoliths. But times have changed, and we're in the era of microservices. Developers are now harnessing edge and cloud environments to create more engaging application experiences. However, the straightforward approach of a single cluster on a single cloud provider may not cut it anymore. Today, developers aspire to deploy their applications across various locations, including different clusters. These clusters may not be confined to the same cloud or region. They can span on different public, private, or hybrid providers. Yet developers don't want to get caught up in the infrastructure or intricate configurations. Instead, they dream of their components seamless running and communicating regardless of their location. That's where the Miro comes in. It handles Kubernetes clusters and deploys applications seamlessly across multiple domains. Miro is a versatile cross-domain resource orchestration solution that brings the management primitives for bootstrapping and configuring a virtualized and container-based environment across multiple domains. The Miro system revolves around 4 key elements: a graphical user interface, GUI, a high-level orchestrator, a low-level orchestrator, and a monitoring system. The GUI lets developers define application components and requirements. The high-level orchestrator then uses AI to determine the best deployment strategy. The low-level orchestrator translates these decisions into real actions, setting up cluster and deploying apps using tools like Kubernetes operators and ETS's zero touch. Finally, the monitoring system ensures everything runs smoothly and maintains seamless operations. The goal is to simplify Kubernetes cluster and app lifecycle management across a multi-domain environment, from creation to dynamic deployment. Now let's go through a series of demonstrations. Let's start from a blank state. No applications, no clusters. To create an application, we have several options to choose from. For now, let's choose from scratch. Creating an application in Miro is straightforward. Simply define its general characteristics, then visually compose its components, relationships, and requirements. In this example, we'll demonstrate how to create a Super Mario web application by simply defining its name and the properties of its single component. Miro allows the user to define and review all the properties of each component. This process includes specifying the image source, configuring settings, defining service endpoints, and setting requirements. These characteristics and requirements are then used in Miro's scheduling process to intelligently determine the optimal location for each component within the infrastructure. Once we're finished, we simply click the deploy button and the entire deployment process is automated. Miro provides visual feedback about the underlying process and all the steps being performed. Let's pause to review how scheduling works. Once we choose to deploy, the high-level orchestrator selects an appropriate AI scheduling algorithm, agrees on the metrics to use, and passes them to the algorithm. The AI algorithm then determines the optimal destination for each component and communicates the decision to the HLO. Let's return to the deployment process. Initially, no clusters were available, so Miro automatically initiated a request to create one. In the top section, we can observe the steps of the scheduling algorithm, where Miro gathers metrics, determines optimal locations for each component, and communicates these decisions across the infrastructure. Meanwhile, in the lower left, each step of the cluster creation process, including provisioning and setup, is shown. With Miro's automated handling of resource provisioning, placement decisions, and deployment, complex setups like this become simple and efficient, making it easy to manage and scale applications across cloud-native environments. Finally, the Super Mario application is successfully deployed in the Kubernetes cluster and ready to use. The deployment is complete, Super Mario is now live, and the cluster is fully set up. We can see details of the Super Mario application, including component endpoints, the application's geolocation, Kubernetes deployment specifics, and metrics for each component. With just a few clicks, the application is online and ready to play, highlighting Miro's efficiency and automation capabilities in cloud-native environments. This process demonstrates how easily Miro manages complex deployment tasks, making applications quickly accessible and fully monitored across infrastructure. Now let's see how to manually create a cluster. Just like with applications, creating a cluster only requires specifying basic settings, the name, data center location, and the flavors for both the Kubernetes control plane and worker nodes. In the terminal, we can observe the cluster being created in OpenStack through Cluster API. Cluster API simplifies Kubernetes cluster management by offering a declarative API to automate creation, scaling, and lifecycle management. It abstracts infrastructure complexities, allowing users to define cluster specifications consistently. By integrating with providers like OpenStack, Miro enables seamless provisioning and management. This streamlines Kubernetes operations, enhancing scalability and efficiency. At the end of the process, we can confirm that the cluster has been successfully created. The cluster is then visible in both the Miro dashboard and the OpenStack web interface. Now let's go to a more complex deployment scenario. Next, we'll create an application using a template, a cat versus dog voting app. We have not only additional components to deploy, but 2 clusters now in place. The template option allows us to quickly design an application using pre-configured settings. Once the application definition is complete, we simply click to deploy it. AI will determine which cluster should host each component. After deployment, we can view the distribution of components across the two clusters, along with the details of each. We can now access the application and vote for your preferred option and see the results. I prefer dogs.
Okay, so for the sake of time, I will just move on. We have actually done actually some kind of benchmarking of the performance. So, for example, we want to deploy backend system of an application, but on two clusters. These two clusters, they are actually sitting either on the same server or on completely two different cloud domains, and we want to stitch between them and make sure that actually the connectivity is going smooth, and that's exactly what Edge Cloud Continuum is about. So here we used two open sources, Lico or Port Node, as you will see. Basically, these are very, very quick results, but just for the creation of a cluster, of course, depending whether you are considering the normal Kubernetes or lightweight version, and depending on the size, the number of nodes that you are involving, just for the creation, you're talking about like few seconds, like 300 seconds for a very large cluster creation. For the deployment of the application itself, depending on the size, of course, like the bigger the application is, the more time it takes, but it is just in the order of few seconds, as you can see here. Now, for the connectivity between, for the automatic connectivity between components that are sitting on completely different clusters, even operated by completely different cloud domains. As I have mentioned, we used Lico or the node ports. Here, what we could observe, when you are running the backend system on a single cluster or on two clusters, but on the local server or on two completely different clusters, two completely different cloud domains, yes, the latency is almost the same, which is acceptable for this use case of streaming. Of course, for other, let's say, ultra reliable low latency communication service, maybe the latency is high. But the benefit is, of course, like when you distribute the backend system on different cloud domains, you gain in terms of the CPU usage and the memory consumption. So it's a little bit distributed, and that, of course, impacts positively the performance of the application itself. We have been also looking into how we can leverage LLM in Miro, and here I will just share with you very quick demo videos that just give the idea. For example, in the demo that you saw earlier, it showed how to create, how to deploy an application from scratch or using a template. But here we can do it with LLM. For example, in this conversational application builder, we can use also LLM to understand better the analytics, the metrics, and also explain the logs, and even onboard development team, so they can understand actually how the system is being developed, and without reading the whole documentation of it. So we start with this example, and then we do the intent-driven analytics, and then I stop because of the limitation of time. So again.
Hello, everyone. Let's see how easy it is to build an application using natural language right here on the Miro dashboard. We start by clicking on the Create Application button. Next, we select the natural language option. The system then asks us for the details of the application. We enter the necessary information, and the LLM checks any missing fields required or asks for a few clarifications. In this case, we need to specify that the Tosca definition is Tosca Simple YAML 1.3. The LLM then asks about the template version, and we indicate it's v10. Once all the fields are collected, the LLM confirms that everything is done. On the right side, we can see the components that have been built automatically using natural language. From here, we can deploy the application just like we would if we were filling in the components manually. Using this method makes building applications faster and more intuitive. We can rely on natural language to handle the setup, avoid repetitive manual work, and focus on what really matters, designing and deploying our applications efficiently.
So indeed, LLM can help at least to create Tosca models in a way which is completely error-free, and so you don't have to worry about the...
Hello, everyone.
Yeah. And then this is the second example. It will be also very quick about the intent-driven analytics and metrics. As you know, one important component of the Miro system is to have quite general monitoring system, but sometimes you don't need to understand or read all the data that you have. So sometimes you just want to know, for example, here, the CPU usage of a service over like certain period of time. You can make that query, and then you will get the data that you are actually interested in. And even like here, and even with certain explanation of how you can read that data. So this will facilitate at least the processing of the monitored data, and it should be user-friendly for the users and also for the administrators. Okay, so with this, I think we can skip this. I don't want to take too much time with you guys. But this is the conclusion. I have introduced the vision of Miro as one key technology of the 6G path project. Yes, we have designed the system with this principle of decoupling the intelligence from the enforcement, and because of that, we can achieve a certain level of AI nativeness. And we have been also exploring how to leverage LLM to make the tool more user-friendly and easier to operate. Okay, with this, I come to the end. Thank you so much for your attention. And yes, we can have questions if you have any.
Thank you, Tarik, for this very interesting, insightful presentation and demonstration. I see one question, but let's reply to the question at the end.
Okay, then I'll stop sharing.
Yes, thank you very much again. Dhouha, the floor is yours for the presentation of the Elastic project.
Okay. Can you see in a full screen?
Yes, yes.
Perfect. Okay, so I'm going to give a brief or introduction and overview to the Elastic project. So the Elastic project is a research and innovation action that is about efficient, portable, and secure orchestration for reliable services. We have just started our third and last year. And we are 13 countries across, 13 partners, across 8 countries, 5 from academia, 5 from industry, and 3 SMEs. So the motivation behind this project is that we would like to realize the full potential of 6G, mainly through mastering the orchestration of the broad range of services and resources of 6G, mainly in the context of edge cloud continuum. And the orchestration of these type of services and resources in this context imposes new challenges, mainly related to security, scheduling, supervision, and efficiency. For example, how to manage lightweight workload at the edge and how to ensure its isolation and portability. Then the serverless orchestration of this workload is in itself a challenge that we also require to be efficient and secure. The third problem that we face is the adoption of confidential computing at the edge or even on the cloud, because despite the benefits of TEs present technical complexity. It presents also a certain cost, since they require specialized hardware, they require complex integration, and it requires also experts for development. And then for the fourth challenge is really to go until the far edge in this continuum to orchestrate the workload with also a certain level of security, and also by taking into account all the various constraints related to the IoT and far edge. So, based on that, the mission of Elastic is to enhance the efficiency and security of service orchestration in the cloud fog edge continuum context. And to do that, we are focusing in this project mainly on combining four key technologies that are innovative and impactful. These technologies are mainly WebAssembly, function as a service, eBPF and XDP, and also confidential computing. And I'm coming back to this to explain how we are combining and leveraging on these technologies. But before, I would like just to clarify our objectives. We have mainly four technical objectives, based on the challenges I have presented. So the first one is mainly to study and analyze the isolation technique in order not only to improve the security, but also to improve the efficiency and portability of these technologies. Then to define, design, and implement a serverless function as a service orchestration in an architecture agnostic manner. Then the third objective is to implement a privacy preserving solution that is also architecture agnostic. And finally, to design and implement efficient, secure edge and far edge workload orchestration that is efficient, reliable, trustworthy, and also resilient. So, so how we are going to do that and cover that based on the four key technologies that I have just introduced previously. So as I said, in this project, we are interested mainly in WebAssembly. We are using it as an alternative to Linux-based containers, since it promises three properties in the same time that are interesting in the context of this project, and that are portability, lightweightness, and also security and isolation. Then the function as a service is leveraged in this project to execute low latency applications, especially at the edge and far edge level, where also orchestration is providing the ability to manage complex workflows. Then function as a service orchestration is also used to carry those WebAssembly containers. Then the third important technology we are relying on, as I said before, is confidential computing. And here, Elastic wants to leverage on TEs to execute in a privacy-preserving manner the orchestrated workload on the nodes. And regarding the portability and interoperability problem that I have mentioned before, this is where Elastic will leverage on WebAssembly runtime in order to abstract these hardware enclaves and their constraints. So finally, we are also relying on eBPF and XDP in order to have real-time monitoring and security scanning, and also in order to have low latency network packet processing. Then I just wanted to give you a quick overview on our architecture and how are we combining these key technologies in an architecture. We don't have here all the components of Elastic, but mainly the building blocks, and layers of the architecture. So we are providing an orchestration layer that provides a set of components and mechanism in order to deploy a WASM workload in an efficient way. You will have a specific presentation of Propeller today presented by Dresco, so I'm not going to present all the details here of this block. One of the very important block we have here is the isolation block that is leveraging on the TEEs, on secure elements, in order to ensure a security and isolation of data in use and also at rest. One of the main contribution of this block is the confidential computing hardware abstraction layer we are providing. Then we have a block about monitoring and detection that leverages on eBPF, and it also provides an AI-based intrusion detection solution. We also have a trust and access control block that allows to verify the system integrity by using advanced and distributed remote attestation solution, and also that enforces secure key management. And finally, we also rely on a communication block that also provides advanced technologies based on eBPF and RDMA to speed up communication. Just some words, if I have some time, Despina, about the demonstrators. We are validating the Elastic technology based on 2 demonstrators. The first demonstrator is about smart connected factory of the future, where Ericsson is providing an IoT data fabric as a native 6G infrastructure capability. This demonstrator relies on IoT data processing using function as a service, and also on WebAssembly, and also on an embedded low power modules for security issues detection. And the objective here is to use lightweight virtualization, and also to deploy privacy-aware mechanisms and elastic stateless and minimal state processing on resource constraints and device clusters. Then the second demonstrator is led by Thales DIS, and it is about migration of a sensitive IT service from on-premise to public cloud. And the objective here is to work on a privacy-preserving confidential computing platform in order to be able to migrate the sensitive IT on-premise services to the cloud. And this use case, this demonstrator relies also on VM-based trusted execution environment, on WASM containers, and also eBPF monitoring. And the objective is to handle TEE abstraction and also remote attestations. Thanks a lot for your attention. If you have questions, I would be happy to answer questions.
Thank you so much, Dhouha, for this presentation. Please pose the question in the chat. I already see 2 questions, and we will discuss them later. Now it's time to move to our last presentation. Drasko, the floor is yours. Dhouha, if you can please stop sharing. Okay, Drasko. You are muted. We cannot hear you, Drasko. If you can please unmute your microphone.
Yes.
Yes.
And do you see the presentation?
Yes.
Good. Okay. So this will be a quick talk about the WASM orchestrator. It comes from the future. 3rd April, I made an error. But you will learn about how do we handle these new challenges of orchestrating WASM images. And I will explain what does it mean and why is it important. So what's the problem that we are facing as a community, I would say, when it comes to the DevOps in general and the cloud deployment? And we saw the pain of lifting and moving around the heavyweight Docker containers. There was so much initiative in making those smaller from the from scratch containers and so on and so on. But this efficientness was really hard to achieve. And the new paradigm that appeared is WebAssembly that has been worked on for a number of years through different projects that were to enable execution of different type of languages or binary code of different type of languages within the browser. But then it became possible through so-called WASI or WebAssembly system interfaces to execute them even on a system. And of course, this then appeared as a very nice or can be a very nice alternative to a Linux container. And then from that side, it's of course appealing to be used in a large-scale deployment. So what do we get with this lightweight? This is what we need: lightweight execution, unified orchestration, so that we can actually orchestrate different type of binaries, not only containers, but different type of binaries, and especially isolated ones like WASM is promising, and that we don't care if it's a WASM container or a Docker container. And then also secure deployment across the whole continuum. So what we saw in the previous presentations were large data centers that can live in Amazon, that can live in, I don't know, Microsoft Azure, etc. But what about all those microcontrollers that live in various devices and let's say, or even Raspberry Pi class of devices and edge gateways and so on. So these are different kind of beasts that we need to handle as well, and that actually enlarge this continuum by a multiple scale. So this is our solution. It's called Propeller. And what is it? So it is an orchestrator that lets you deploy WASM containers, and not only WASM containers, also binaries, but WASM, as I said, is let's call them nano containers, from cloud to microcontrollers. And it abstracts the whole deployment process so that you don't care if you are deploying on a heavy server or a ESP32 type of microcontroller that runs Zephyr real-time operating system or similar. So how is this possible? So what we of course missed, and there was a huge initiative within the Kubernetes community, CNCF, within Linux Foundation, to add a support for WASM into the Kubernetes. This is an ongoing effort. It is simply something that Kubernetes is not built for. And so this is slowly changing. But what we wanted is, at least at the beginning, one standalone binary, a manager that is, of course, clusterable and scalable. And we wanted an agent that we called Proplet here as an analogy to Kubernetes kubelet to run on each of those end nodes with certain requirements that we identified, and that is that the same Proplet should run on as I said, huge server in your data center, but also on a very poor microcontroller. And so let's say you want to run this Proplet on a Linux machine. It seems quite straightforward of an agent running there. But when it runs on the microcontroller, then you have a type of constraint first that what will be the runtime in which you will run your WASM, let's call them WASM containers or WASM images. You need the runtime that will be running on the microcontroller. And luckily, there is a huge effort in building so-called WAMR, WebAssembly runtime, that is made for constrained devices and runs in the Zephyr RTOS, which is the most popular open source industrial real-time operating system made for microcontrollers. And then you will probably need some kind of a protocol that is very lightweight in order to enable your service mesh. And this is where we choose MQTT, but we can also choose co-op or similar, because what we did is that there's a central broker that serves as a service mesh is something that we call SuperMQ that also comes from abstract machines and is a project that's been here for a decade for event management and IoT applications. So we built a service mesh on top of it, and it gave us out of the box all the necessary access control and permissions over different topics. And so using unified namespaces, MQTT, and similar to Spark-Plug-B, for example, protocol, we have successfully built a service mesh that works for both microcontrollers and large-scale applications. One of the challenges was how to pull those images from OCI registries, because we wanted to use the same approach as you would use with Kubernetes, so the enterprises are used to this. So just tuck your WASM module there in an OCI registry, and then your arbitrary, Proplet that runs on your microcontroller somewhere in the field, in the, let's say, in an agricultural environment, somewhere completely autonomous on a battery-powered sensor, can pull this WASM module directly from OCI registry. But since OCI registry speaks only HTTP, we created a small proxy that can transfer this to either co-op or MQTT, so that you actually pull then your images. Proplet or the agent on the microcontroller can pull this image and then deploy it safely within a WAMR, in this case, runtime, or here WASM time, or any other WASM runtimes that of your choice. So this is completely configurable. So we are especially proud to achieve simplicity. Simplicity is hard, as Rob Pike, the creator of Go, says it. And so, for example, what we want is that everybody develops in their language of choice. You are writing C, you are writing Rust, you are writing whatever language. Fantastic. You can compile this in a WebAssembly module. First step. Second step, just register your workload in OCI compliant registry as you would do, or as your enterprise kind of policy is. And you don't even have to do this. You can send it directly through Propeller. But let's say we want to follow this standard. We have flexibility, but you put it in OCI registry and then you deploy it wherever you want. So as I said, all over the globe, on any microcontroller, on any computer, on any server, wherever. And then what Propeller gives you is this monitoring of what is actually happening with each of the Proplets. Of course, there are agents that are sending back telemetry, but they are also monitoring your isolated workload or true function as a service and sending telemetry back to the manager, which then can present you this in a nice way or forward it further through a service mesh. So what did we achieve with this? So of course, cloud edge orchestration, effortless deployment of WASM workloads, very fast boot time. So this is critical. WASM has a near instant startup. This is something that is used today, let's say by Fastly or Cloudflare for so-called workers or Lambda functions. The WASM startup time from the cold start is under a couple of milliseconds. Compare these to containers or even virtual machines. This is definitely the future of cloud computing. OCI registry support, we worked on this, not only us, but CNCF community as well, and through some different open source projects. This was now completely enabled within an OCI, so that we just leverage on an open source project and extended OCI support, with addition that we actually are capable of putting here the encrypted workloads and decrypt them through attestation, which I will show you later, that Propeller has much more than it shows here on the glance. Security and the core, I will discuss this in more details. Powerful service mesh, as I explained you, this really is standing on the shoulder of a giant. SuperMQ has been there for a decade. It's been used all over the world. It's an extremely powerful event broker that is multiple protocol, maybe even unique in the world, that can speak co-op, MQTT, HTTP, WebSocket. And it's been proven in practice, and it comes from us. It's open source, Apache 2 license, and we used it as an internal component of the Propeller. And it gives you a true function as a service. So that means whatever happens in your system, a function can be sent there immediately and deployed within milliseconds, right? Very quick cold start and very quick deployment on an arbitrary node. There is a UI, but I will just glance through this because UI is the least important part of the story. What I just wanted to give you an idea through this UI, that there is a complete job management, and that we have built also a Kubernetes operator. So Propeller works standalone, but it also has a Kubernetes operator so that you can add it to a Kubernetes and schedule your tasks to Kubernetes. But what will happen is that then Propeller will schedule WASM containers to the, let's say, microcontrollers. We have all the logs of everything that is happening on each individual node, as you would expect from this kind of solution. The manifests are individually written per proplet per workload. We are capable of embedding policies in those manifests, and this is something that especially we are working on now in the last year of Elastic Project together with Thales. So Thales brings a policy-based operator or orchestration policy decision point and enforcement point, and we are integrating with this sophisticated piece of technology to add it to the Propeller so that we can enforce policies upon the execution of those WASM workloads. We are working more towards visualization of the network, but these are just kind of side information. I wanted to show you some kind of trivia, interesting stuff that we played with on a $4 microcontroller. We were deploying, like here, 24 concurrent WebAssembly instances, let's say just for fun, but we had also two standard memory services that were running, and on top of that we were deploying functions. You can read more about this in the blog. I left here link, and you will see that actually this is now a much less challenge that we than it was before, right? And those are completely isolated, quasi-isolated nano containers, if I may call them like this, super simple to deploy through Propeller. One of the things that were a main topic of the Elastic project are also trusted execution environments. So for those who don't know, these are initiated as a CVM, so confidential virtual machines. Now there is a variant that is a container or built on a kata containers that are in the essence, let's say, mutant between virtual machines and container layer. And so what did we do there? Well, we extended a Proplet agent so that it is aware of the trusted execution environment specifics, that is capable of fetching what is called attestation proof or attestation report, and follow the flow that is prescribed by so-called COCO project that came out of IBM and Apple and is part now of CNCF Linux Foundation, and becomes de facto standard, in which the attestation agent fetches the proof and presents attestation report to so-called key broker service, that then and only then, upon the hardware attested proof, releases the key with which you can decrypt the workload. So practically with that, we are keeping a complete integrity, proving that we are running in trusted execution environment, proving that the WASM workload is downloaded from the OCI registry encrypted inside the trusted execution environment, which completely encrypts the RAM, and that even an operator, a CSP, a cloud operator, cannot actually see within the trusted execution environment, and it's completely, the RAM is completely encrypted, everything that executes here, and only upon the valid attestation report, the key is released directly in the enclave via a mechanism that we developed that is called a tested TLS, and is a pending draft in IETF standard in a group called RATS, Remote Attestation Group. And you can read more about this again on our blog. We are really trying to publish all these new things there. One more interesting thing that practically fall into our lap, and once we had this fantastic orchestrator, we said we can now actually do a federated learning. So as Elon Musk put it, the future language of AI is Rust, not Python. So the writing in Rust your algorithms that or models, then compiling them to WASM is kind of a natural future step. And what we did is that we added federated learning coordinator. I would say this was a more trivial thing to do than to write the whole orchestration infrastructure. And of course, the aggregator service, completely open source, and obtained actually obtained a federated learning orchestrator so that you can run a training in a federated manner on arbitrary microcontroller, on arbitrary server, even within a trusted execution environment, meaning that your model, when it goes for a training on the edge, within a trusted execution environment cannot be stolen, because the owner of the infrastructure cannot see anything that is happening within a trusted execution environment. They can put the data locally, their data never leaves the premise, but they provide trusted execution environment, a black box in which you put your model for a training in a federated mode. So this is achieved, and again, there is a blog post here about it. As I mentioned, everything that we do is completely open source, Apache 2 license, no hidden patents useful in industry. There is I would say the bigger and bigger group working on this because it really starts to attract attention. We presented this I would say in the middle of the project of Elastic, so 1.5 years ago, in the KubeConf, so the Kubernetes conference organized by Linux Foundation in Salt Lake City, USA, on the WASM part of the conference. It really drew a lot of attention, and what we saw, so let me skip this, what we saw that there are practically two big competitors. So of course Microsoft is doing on this also, but there is Pin Ferryman. So this is a team that came out of Kubernetes core team. Then Cosmonic, who is building the WASM cloud. But I would say that Propeller, at least to my knowledge, is the only European competitor. So you can see in this cloud environment, this starts to be very serious when it comes to the innovative solution that we are bringing. Let me come back just quickly to this demo. I left just a link here, and I guess the slides will be shared, but in the demo you will see that I don't want to go through it now, but you will see that it's actually a functional product, and you can also download it and test it. And you will probably recognize those YAML definitions from Kubernetes. So we really try to keep stuff as simple as possible and aligned to the known best practices, so that it gets any DevOps engineer extremely easy to run, and you just need to put some information about service mesh and some credentials that are then handled by our SuperMQ internal mesh broker, which provides us with fine-grained security policies, especially for messaging, exchanging information between proplets and manager. And then there are these resources that you can select, CPU, memory, and so on. And we are adding those, adding a variety of policies, actually. And this is a future work that I mentioned together with Thales, is to extend this on a new level of security policies, and based on those policies run certain workloads. So what's the value for Elastic projects? Propeller became practically a core orchestration component, the component that runs a lot of solutions within Elastic, and is used in both of our demonstrators, one that is run by Ericsson in a smart factory context, the second that is run by Thales in a migration of services from on-prem deployments to cloud, because now it becomes possible thanks to trusted execution environment system. And it contributes to trusted execution, portability, of course, because it's, first of all, you can run it everywhere, even in browsers, right? That's the whole goal of WebAssembly. But even more important for developers, it's polyglot. You write in any programming language and you compile to WASM. So the key benefits: one orchestrator, all environments, lightweight. I said very fast start times, but extremely lightweight binaries or the microcontainers that you move over the network, secure by design. So the WASM or WebAssembly runtimes and the WebAssembly in general has a extremely big, I would say, research action on doing the isolation around WASI interfaces. This is, by the way, also one of the topics of Elastic projects, and we have partners who are really deeply involved in this, and enables a next-gen cloud. So in short, it enables a new paradigm, write once, deploy anywhere, from cloud to microcontrollers. Thank you for your attention.
Thank you, Drasko, for your presentation. And with this, we have finished with the presentations, and now it's time for our Q&A session. I will already see 2 questions in the chat. I think both of them are for Tarik. So, Tarik, what are your recommendations to policymakers?
That was a question to me. I'm sorry, I don't know what could be the recommendation to the policymakers. I don't know. Maybe give us lots of funding so we can do lots of research. I think I answered the question that was about the cluster creation.
So the question was, does the system take into account the risk of unnecessary cluster creation that could lead to excessive cloud costs?
Yes, it can. And I think I explained that the system creates cluster only when specifically requested by a user, an application developer. Of course, there should be like a default cluster that can be used by all the users. But if somebody wants to have his own cluster for whatever reason, scalability, security, whatever, then yes, that can be possible. And of course, like if there are multiple clusters existing, and for example, one of them is not being used, we can actually, migrate the ones that are actually used in the one which is not heavily used, and then get rid of the other cluster. And in this way, you save cost, you save energy, you save lots of things. Yeah.
Great.
Are the decisions of the high orchestration in Miro centralized? Yes and no. Yes, because you have this Miro orchestration system that has to, take decisions for whatever infrastructure it is in charge of. But if you think about, for example, Miro as being an orchestrator of, let's say, just an edge cloud, which is in a single city, then there is another one in another city, then it becomes distributed. Yeah. So that's why I answered by saying it's centralized, but it's also distributed. It depends on what is the domain of administration of one single Miro orchestrator.
Yeah. Actually, Tarik, indeed, it was my question. I wanted to have an idea about the process of decision itself, that is, and the AI agent. Are all of them placed in an only one domain that takes decision for all the other domains for their orchestration, or is it a distributed process?
Yeah. As I mentioned earlier, it depends really what is the what infrastructure the Miro orchestrator is actually, say, governing. So basically, if you can have a Miro orchestrator which is in just one city, and then it's operating or administrating the cloud environment of that city, and then you have another one which is in a completely different city, and in this way you have distributed kind of orchestration. The other thing also, if you remember, I spoke about this AI nativeness. So for example, if you want to take a decision which is just relevant to a certain location, in the data filter that you are actually building, so you can apply to it your analytic algorithm, you could specify that I'm actually interested in only this specific data, which is coming from only this specific area. And that's where you apply your AI algorithm. And in this way, you can actually achieve certain decentralized decision making. So depending on what you want and what you filter as monitored data. So I hope I answered your question.
Okay. Yeah, thank you.
Great. I like a lot of this interaction because the collaboration of the two projects just started and more activities are coming. So it's good that we define and discuss things.
Yeah, I found it also very interesting because one of the limitations, let's say, that we have in Miro, that we need certain requirements in terms of CPUs and memory so we can operate it. So definitely we tried it. We tried to work it on, let's say, microcontrollers with certain limited processing capabilities, and it didn't work. I mean, we had lots of issues. So I was very impressed with the work that you do in Elastic, particularly, you're solving this issue of, yes, you can run, containers also on extreme edge nodes with limited processing capability, cheap as $4, as you mentioned, Raskov. So that's a good thing, actually.
Thanks, Tarik. Then I would probably, if there are no other questions, I would like to ask for some clarification. I know that you explained it, Tarik, about this AI nativeness, because we have an idea about the definition of AI nativeness, but I don't know if I understood it well. You defined it in Miro as an ability to update the models that are used for your decision points or something like this. Is it this the idea of the AI nativeness of
Yes.
Miro?
It's half the story, because the second half of the story is that actually you can replace, upgrade, let's say, AI models without impacting the process of the system itself. That's actually what I meant by AI nativeness.
Yeah, and do you have use cases where there is a requirement of updating the model itself for AI during execution?
Not specifically, but I think there is always need for better AI algorithms that can make better decisions, because these AI models, they keep on being, I mean, we don't do any AI models, we don't do any training, but let's assume that somebody does an AI, like what we have nowadays, even with LLMs. Like today you have a model which is powerful for whatever purpose. It's operating very well, but then you keep on training it against different data, and then you find that actually your model, the new one becomes much more, let's say, smarter or more efficient, and then you want to replace it. So, I mean, that's what we meant. And also, since the whole idea is not to be, how do you say it? Not to be kind of dependent on one single cloud domain. For example, instead of just having your system running on like just Amazon, I mean, with Miro, you have the possibility of deploying your service on different cloud domains, not only a specific one, and you don't have even to understand how they operate. I mean, that's actually what Miro is trying to do. The same thing with the AI algorithm. For example, today, let's say that the system buys an AI algorithm which is coming from vendor one, and it's very powerful and it's working. But then tomorrow there is another vendor who is making actually a completely different AI model. Then you should be having the flexibility of saying, okay, I'm not going to extend the license of my model, and I will get it from somebody else, from the one who is. So that's actually the idea. Specific use case, I don't have, but I would say that this is something which is, I would say, generally needed.
If I may add to this interesting discussion, one of the important points that we looked at within Elastic, that when it comes to deployment of AI, and having in mind that we wanted to leverage on trusted execution environment, we wanted especially to take a look at this inference of the LLMs, let's say, because it is a practical problem today. We want to, with this, we can really solve something really practical for the enterprises and SMEs, for the use of AI, on which everybody complains and want to increase the use of AI within the enterprise. So what it happens is that you are sending those prompts to the LLM that lives somewhere either in somebody else's computer, or even if you deploy it within on-prem, within enterprise, it is still, I would say, can be a victim to the internal threats, especially in the larger enterprises where it's more difficult to secure access to the particular LLM server deployment, right? So when you put this into a trusted execution environment, when the LLM is served from the TEE, then as it by hardware encrypted in RAM, and you have attestation on your client side that establishes so-called attested TLS that I mentioned directly into enclave and towards the LLM server, then all the prompts are completely encrypted. They come to the server within a confidential VM or a confidential container. The LLM server processes them, but this processing is protected in use, not only in transit and at rest, but also in use, so nobody can dump your RAM and see your credit card number or whatever prompt that you asked. And then the results are retrieved by the same channel, same encrypted channel to the client. And so that way, you're really removing that security, the biggest security problem, and that is the leaking of proprietary information when the employees start using LLMs, and they are today using them, of course, in everyday work. And this is something that we've been working on extensively in Elastic Project. So how do we orchestrate those TEs? How do we easily deploy them? How do we run LLMs in them, not only arbitrary algorithms, but especially, those types of applications that are used today? And how do we protect privacy, GDPR, and privacy in the sense of prompts that people are sending to ask those questions?
Yeah, excellent insights. I agree with you 1 billion%.
Great. I see we are approaching the end of the webinar, and I'm very happy there is no time for my questions because of this very interesting discussion. Before we close, we do have two final questions. Jelena, if you can launch the second part of the poll, just a little bit of feedback of what people here want to see next, and if this is considered as an interesting webinar. So, Jelena, when you are ready, please launch the poll.
By the way, it was very interesting to notice that scalability was the #1 challenge in Edge Cloud Continuum. Although for me, I would vote for the automation and security, actually.
Okay.
I was voted for interoperability as somebody who comes from IoT world, but definitely interesting.
Yeah.
And Dhouha, what about you?
Yeah, I would say interoperability. And especially for IT and OT. Yeah, totally agree with Rasko.
Okay, so the window is here. What would you like to hear more about? Architecture, use cases and real-world applications, technical implementation, or results and performance? And the second question, how useful did you find this webinar? We really hope that you found it very useful or useful.
So the speakers also can vote, or no need?
I voted.
There is a bias a little
I
bit.
said that it was very useful.
Yeah, you see.
I also did the same. Because at least for our collaboration between the both projects, it was very useful.
Yeah, a joint paper is coming, or we are also discussing the adoption of some of the Elastic technology. So this was the first step, and I think it was a very good one. So we can close the poll now. We came to the end of today's webinar. I would like to sincerely thank all our speakers for their excellent and insightful presentation. It was very interesting to see the different approaches today. I would like to thank you all for joining us today and for your active participation. If you have any further questions or Would you like to continue the discussion? Please feel free to reach out to us in any possible way. Thank you very much, and I wish you all a great rest of the day. Bye.